So, finding limits analytically. Very, very straightforward process. Straightforward, as you know, does not always equal easy. All right? So, step one. Take the limiting constant, chuck it in for x, and simplify. Drop the limit because by substituting it in for x, you are applying the limit. In some cases, that's all you need to do. All right? Those are the situations you root for. However, we know that they're not always going to be like that. All right? So if you can plug in and get a real number as an answer, then you're done. All right? So we like those. Those are our faves. But then you come across something like number 6, where you plug in, and I'll show you. You plug in the 0 for x. And I'll show you the act of plugging it in because, and in all honesty, this is the most commonly forgotten step. It's really strange because I'm telling you the first step is to plug in the x value. That is the most commonly skipped or forgotten step because people will assume that the question is always going to be one of the more challenging ones where you have to do some algebra. So they'll gloss over that. They'll try to do algebra all the livelong day. Period comes to an end, and tears are streaming down their cheeks. I go up to them and say, "What's the matter? Your test is all wet." And I say, "I'm very upset. I have not been able to figure out this problem." And I'll say, "Did you try plugging it in?" And then you'll look daggers at me like I did something to you.
Why did you give me the answer?
Yes. Why didn't you see me in such dire straits much sooner in this process? The reality is, it happens. You know, you gloss over those kind of steps and you realize after the fact, oh, it was supposed to be a gift, and I did not receive the gift properly. All right. So, but in this case, it's not a gift. I plug in the 0. 0 plus 2 squared minus 4 all over 0. I get 0 over 0. All right? When you simplify, you plug and chug. If you get 0 over 0, that's never going to be your final answer. It means that there's more work that can be done. All right? If you get a numerical value other than 0 on top, but a 0 on the bottom, okay, so let me just talk a little bit of vocabulary. This form is known as the indeterminate form. I gotta move my toolbar over. It's not considered undefined. It's
Not
What is the difference between the word indeterminate and undefined?
indeterminate is the case where you have a 0 on the top also, instead of just a 0 on the bottom. Undefined
Is just 0 on the bottom?
is just 0 on the bottom. So all right is a over 0, where a is not equal to 0. I guess it depends on the brand. I'm gonna move my toolbar out of the way here. All right, so yeah, indeterminate means you got some work ahead of you. But it also means that if you do that work, you'll get an answer. Right? So that's good news. If you get undefined, it means that you probably want to go to a graphical approach. All right, there are analytic approaches that'll get you around the undefined situation, but they're not as convenient as the graphical approach. All right, so if you get undefined, go for a graph. If you get indeterminate, do some algebra. So the question becomes, okay, well, what kind of algebra? The simple answer to that would be, well, do the opposite of what they did. All right, so it looks like they have some kind of factored form here. The opposite of factored is distributed. So distribute it out. X squared plus 4x plus 4. All right, the big caveat here is you got to distribute it correctly. So that's kind of important. Something else to bear in mind, just because I tell you to do something analytically doesn't mean that you can't also do it graphically. All right, so we know how to handle this kind of problem graphically. I showed you all the shortcuts yesterday. All right, so you could figure out what the answer is supposed to be and then work the algebra to get that answer. At least you know what you're aiming for. All right. So if you screw up the algebra, like you accidentally distribute incorrectly, and you can't come up with the answer you got graphically, you'll know, okay, I probably made a mistake when I distributed. Right, so the 4 and the negative 4 cancel. So I'm looking at limit as x approaches 0. I'll show the intermediate step, x squared plus 4x over x. What do you think I could do on the top? Factor. Take out that x. Absolutely right. And after I pull out that x, I can do what? Cancel it. Get rid of it. So limit as x approaches 0 of the much simpler expression x plus 4. Now apply the limit. So plug in the 0 for x. And it's 4.
Do you have to write limit blah 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 every time?
Every single, and I'm glad you brought that up because I was just about to address that. So next week when we start reviewing for the test, I'm gonna give you little exit tickets. You've seen exit tickets before, yeah?
Yes.
Yeah, you've had various different experiences with different types of exit tickets. These exit tickets will definitely assess the different content, but one of the things I'm going to be looking for is the proper notation. All right. So I want to forewarn you about that. Proper notation of the limit is the way I'm writing it here. If you deviate from that, you're going to lose credit, not because I'm a jerk. Okay, partly because I'm a jerk, but mostly because if you don't write it the correct way, you're not really speaking the language of calculus. All right. And what does that mean? Well, when we start talking about derivatives, it's going to rely heavily on your fluency with limits. All right. So if you don't understand the language of limits, then you're not going to understand the language of derivatives, which is the foundation of everything that comes after that. All right. So it's very important. I mean, just look at this as like learning how to conjugate a verb in a Spanish class. All right. That's how important the notation is. All right. So how do you not write a limit? You don't write it as limit equals x plus 4. As that, you don't do that. I've seen that before. Final answer, you don't write limit equals 4. You don't write that. These are a bunch of different things you don't write. What do you write?
Just 4.
What I wrote. Yeah. Yeah, you know, you're better off just writing the 4. Write the original problem, put an equal sign next to it, and a 4, and you're better off doing that than writing this nonsense. All right, because this is not something that's mathematically correct. It's actually meaningless. All right. Now on your end, you're like, what's the big deal? On my end, it's like, well, you're not really going to truly demonstrate knowledge of calculus down the line if you don't have the notation down for the early stuff. All right, that's how important it is. All right, feel free not to believe me right now. We'll reconvene this conversation in January and reflect back, and we'll talk about it, and you'll see. All right, and we'll all be on the same page, I think.
But for steps like these, you don't use like just the match.
Still need a limit. Every step. It's a terrible pain.